Let's explore this official GMAT problem. To get the most out of this video, pause the recording now and solve the problem yourself. The correct answer is B. Identifying what kind of situation this is will help us choose an efficient strategy. We're combining two seed mixtures X and Y, and we need to know the proportion of X in the final mixture. To help myself understand what's going on here, I'm going to imagine a couple of examples. If the mixture of X and Y was almost completely X, let's say 99% X, then it would have close to 40% ryegrass and 60% bluegrass. If the mixture of X and Y was almost completely Y, let's say just 1% X, then it would have close to 25% ryegrass and 75% fescue. In reality, I know that it's somewhere in the middle because the mixture of X and Y contains 30% ryegrass. Those little examples help me understand that the ryegrass is the important thing here. We can ignore the other ingredients. And the examples also clarified to me that we have a mixture problem. This opens the door to a particular strategy. Let me show you. If we organize the information, we can see that the percentage of ryegrass in the mixture must be somewhere between 25 and 40%. If we combined X and Y in equal quantities, then the percentage of ryegrass in the mixture would be exactly halfway between 25 and 40. That's 32.5%. That's not actually the case, so that I can see that answer choice D is incorrect. Remember that the answer choices are all about the percentage of X in the mixture, not a percentage of ryegrass. They're trying to confuse us with lots of different percentages, and we need to keep track of what all those different percentages are of. 32.5% ryegrass would indicate a 50-50 mixture of X and Y. But in reality, the percentage of ryegrass in the mixture is closer to 25%, so that it's weighted towards Y. Here's the strategy. I can think of this situation as a tug of war between X and Y. If there's more X than Y in the mixture, then the percentage of ryegrass will be pulled towards 40%. If there's more Y than X in the mixture, the percentage of ryegrass will be pulled more towards 25%. Let's continue writing out the information. X has 40% ryegrass, Y has 25%. The mixture has 30%, so that it's closer to Y. Y is winning the tug of war. So that less than half of the mixture is X, I can eliminate answers D and E. I'd also estimate that the answer isn't A, as my diagram shows that the percentage ryegrass in the mixture is towards the middle of the scale. Now let's be precise about the numbers. Y has pulled the mixture 10 percentage points away from X. X is losing, but even so, X has managed to pull the mixture 5 percentage points away from Y. If I were to score this competition, then X would get 5 points and Y would get 10. This means that Y is doing twice as well as X, and that there's twice as much Y in the mixture as there is X. This means that 1/3 of the mixture is X, and the correct answer is B. To conclude, this tug-of-war method involves sketching out the information and noting the distances between the different percentages. The key point is that these distances are proportional to the composition of the mixture. Thinking about who's winning the tug-of-war helps me be clear that the 10 percentage points relates to Y, and the 5 percentage points relates to X. With a little practice, this method is almost certainly faster and safer than making equations. And notice how I was able to use it to eliminate some answers even before I made any calculations. Check out the link below for a follow-up task.